Welcome back to Aurora Tech Channel. Today, I will review the SnapMaker J1s IDEX printer. This machine has an independent dual extruder that can print simultaneously, so you can print two models at the same time or print a single model with two different filaments. This machine costs around $1,000, so let's take a look at what we can get from it. The print volume is 300 by 200 with a Z height of 200, but when printing two models at the same time, this print volume will be cut in half. The motion system is using linear rails on the X and Y axis and linear rods on the Z axis. The extruders use a module design, and you can remove two screws and pull it out. This allows you to easily switch to hardened steel or larger diameter hot ends. The maximum temperature of the nozzles is 300 degrees Celsius, and the heated bed can reach up to 100 degrees. The heated bed is a PCB heated bed with a few calibration spots used to do bed leveling and to set the Z offset of both extruders. The square in the middle is used to set the X and Y offsets, just like how you use a probe of a CNC machine to detect the size of the stock. So, you don't have to print those lines and use a ruler to manually calibrate the X and Y offsets of the extruders. In addition to the part cooling fan on both print heads, there's also an auxiliary fan that provides strong cooling for fast printing. The firmware is their own highly modified Marlin-based firmware, and I haven't seen any IDEX 3D printers working with Clipper firmware in the market yet. The machine is fully enclosed, it has a 5-inch touchscreen, filament sensors on both print heads, and LED lights. It supports Wi-Fi printing over your local network with their own Luban software, which can work with other SnapMaker 3-in-1 3D printer, laser engraver, and CNC machines. This machine is taking a different approach than making another budget clipper bed slinger or trying to clone a BambuLab A1 as much as possible for a cheaper price. So, let's test it out and see how it works. I would like to thank SnapMaker for sending us this machine to review, and I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500 millimeters per second while maintaining a flow rate of up to 25 millimeters cubed per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA Pro is also affordable at just $16.99 for a 1 kilogram roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. They have recently launched new filament colors, as well as the Vision Enclosure Kit that includes all the necessary parts to fully enclose your BambuLab P1P. For more information, please visit voxelpla.com. The printer is shipped with the retail box. It comes in one piece, so all you have to do is remove it from the box and remove all the protective materials. Besides the machine, there's a tool and accessories box which contains the auxiliary fan, 2 spool holders, some cables and tools, and the user manual. You don't need to assemble anything for this machine. All you have to do is hang the auxiliary fan at the back and snap the 2 spool holders into their positions. Once the machine is on, the color touchscreen will run a wizard to guide you through the whole calibration process. We have to remove the PI-coated glass bed from the machine, as it will use the heated bed underneath for calibration. First, it will heat up the nozzles and bed and remind you to clean any excessive filament residue, and it actually came with a brush for you to do that. Then, it will use a 3-point leveling system, using the nozzle as a probe to sense the 3 points on the PCB heated bed. After that, the screen will show which direction you need to turn the knob and try to get close to the center of the green area. Do the same to all corners. Then, it will calibrate the height of both extruders using the same method. This time, it requires you to loosen the right extruder so we can adjust it and make it the exact same height as the left extruder. Once they're at the same level, we can tighten the right extruder back. Next, it will calibrate the X and Y offset. As you can see, there's a square cutout at the center of the PCB heated bed. Like how we use a probe on a CNC machine to find the edges of a stock, it uses the same method to calibrate the X and Y offsets of both extruders. After it's done, it will print a sample object to verify the result. The dual extruder switching is pretty fast, unlike a multiple filament system, which requires 2 to 3 minutes to flush the previous color. So, using a dual extruder for multiple color printing is much more effective. The test model is done, and there is some stringing, but I think the alignment is alright as these tiles are not sticking together. The screen is asking if they're separated, and other than how the Z offset is a bit low, all the layers are separated except for the first layer, so I'm assuming this result is okay. Finally, it will calibrate input shaper, and since their firmware is based on Marlin, it doesn't support using an accelerometer, and it still requires you to do the traditional way, like you would on a Marlin-based machine like an Ender 3, which is by printing a test model and seeing which part printed better to manually calibrate. After the print is done, we need to pick which part was printed better. For the Y surface, I think this part has less ringing, so I will select it on the screen. For the X surface, I will pick this part of the screen. The calibration is now done. The screen shows that a firmware update is available, so I will just update it to the latest one. After that, I will connect it to my Wi-Fi network and load some filament. Let's start with the sample 23-minute benchy. I will use mirror mode to print 2 at the same time. When the printer is printing at a high speed, while the doors and top cover are open, the sound level stays at around the low 60s in decibels most of the time, which isn't too loud. It is actually on the quiet side compared to other Core XY machines with an auxiliary fan, which can reach the high 60s to low 70s in decibels. The print finishes in around 26 minutes, including printing the skirt, parking the extruders, and lowering the print bed to the bottom. The surface is not that clean, but it's not too bad for a Marlin-based firmware. The cooling of the front is good, and the strong auxiliary fan and the cooling fan on the print heads provide sufficient cooling for high-speed printing. There's a little more stringing for the gray one than the red, even though they're the same brand and same type of filament. The model may be sliced too aggressively for the speed, and the chimney part of both benches didn't slow down at all, resulting in some cooling issues. As there is a silent mode which will slow down the print speed a little, I will reprint the file with that mode on and see if we can get a better result. This time, the print took 34 minutes, which is about 30% longer than before. The surface has improved slightly, there's less ringing, and it looks cleaner. The cooling at the front is also similar, with no significant difference. The surface quality of the red one has improved even more noticeably than the gray one due to the shiny surface of the filament. The front of both benchy models looks similar, and there's no significant difference in cooling as well. Next, I will try to print the number slider to test the clearance. I will use red for the body and gray for the top few layers of the tiles. On the first try, the Z offset is a bit too low, and the filament is also squeezed too much, so the tiles are too close to each other. So, I will manually adjust the Z offset to leave more space between the nozzle and the bed and restart the print. This time, you can clearly see gaps between tiles on the first layer. The second extruder kicks in and starts printing some gray color. The print finishes in around 3 hours, which is a bit slower than a single color model. There is some stringing on the surface, the bottom is printed nicely, and the number slider can slide smoothly. Then, I will test the retraction by printing the honeycomb box. I will use copy mode using both extruders. The extruders are working pretty well, as this model requires extruding a tiny bit of filament and retracting it immediately. However, I have adjusted the Z offset a bit too high for the number slider. The bottom of this print is not sticking too well, and the corners are warping, but I will just let it finish and see the result. The print finishes in 2 hours and 32 minutes, which is in line with other new clipper machines. As the model is small and doesn't have much room for acceleration, this model is for retraction testing, so despite the Z offset being set too high, the retraction is very good. These three are printed with the same red VOXELPLA Pro, and in terms of retraction, the SnapMaker J1s is performing better than the QiDi X-MAX 3 and is not far from the BambuLab A1. Up next, I will do a tolerance test to see if the parts can fit well with each other. The print finishes in 3 hours and 2 minutes, and as this model is small, the speed is in line with other new generation machines with clipper firmware. However, the square can only clear 0.225mm and 0.2mm, and then got stuck when trying 0.175mm, which was mainly caused by these overshot corners, but I will talk more about this later. For the cylinder, it could fit all the way to 0.075mm and finally got stuck at the tightest 0.05mm, which is pretty good. Then, I would print the Robo Alpaka to test the surface quality of decorative prints. This model is much slower than other clipper machines, which normally finish in around 4 to 5 hours. The print quality is alright, still not the best or the worst, but let's take a look from 4 different angles and compare it with a few other machines. Compared to the Creality K1, the surface quality is similar, but the clipper-based K1 prints faster. Compared to the BambuLab P1P, the P1P prints faster with better surface quality. As this machine is marlin-based, let's also compare it with the Prusas. Compared to the MK3, the print quality is similar and the MK3 is even slower. When compared to the MK4, and this model was printed by the stock firmware at a slower speed, the print speed of the MK4 is slower, but the surface quality is much better. Next, I will try a dual color print and use their slicer to add colors. It has a paint tool similar to the Bambu Studio, so you can just click on the areas to paint on colors. Since the surface of this Groot model is not that easy to select, I will just make Groot's body mainly brown with some black, as the real Groot also isn't pure brown. The estimated time for this model is over 11 hours, but for a multicolored model, that's pretty fast. If I printed this with multiple filaments with a single extruder, like the BambuLab machine, it would take almost 30 hours, as most of the time would be spent on switching colors and flushing the previous filament inside the nozzle. I think printing this kind of dual color model can really show the advantages of a dual extruder printer, as it wastes pretty much no time to switch colors, taking just a few seconds to wipe the nozzle on the prime tower. The print took 11 hours and 46 minutes to finish. Without flushing the filament to change the colors with a single extruder, it's not only faster, the amount of wasted filament is also minimum, less than 20 grams for the prime tower, for a model that weighs 225 grams. There is some stringing, but after some cleanups, the model looks pretty nice and is fully functional. Then, I will print some camera adapters and lenses with PLA using PETG as support. Printing this adapter for Canon's old FD lens to an EF mount took less than 2 hours. The PETG support can be removed easily, even if I set the distance to 0, as these two types of filament don't stick together. And it also fits nicely on an old EF mount camera. I will also print another lens cover for an even older camera. This kind of spring mechanism lens cover is hard to print, and it's pretty challenging to remove the support without damaging the model and still having it functional. It took around 44 minutes to finish. The PETG strings a bit, but as PETG doesn't stick to the PLA model, it can be easily rubbed off, and these two supports can also be easily taken off. The spring mechanism works very well, and it also fits perfectly on this almost 50-year-old camera. Then, I will print an adjustable wrench from 3dprinted.hardware.com. I normally just print the nose pliers and some simple wrenches on other machines, but for this dual extruder, I will use polycarbonate for the model and use some high-temperature quick-remove support filament from Phaetus, which can print up to 280 degrees Celsius. The result is pretty good. The polycarbonate wrench stuck perfectly to the bed with glue. The support material is also easy to remove. It's not as easy as removing PETG from PLA, but it's still removable and doesn't damage the model. This wrench actually works. It's not super smooth at first, but after moving it back and forth 10 times, it becomes quite smooth. Finally, I will also do a quick run for other materials, starting with PETG. The penholder's overall print quality and surface quality is in line with other fast printers, and although PETG can't print quickly at all, being printed at around 120 milliliters per second is still pretty good. As this printer can be fully enclosed, I will try to print the crate with ABS. My garage temperature is around 18 degrees Celsius, so when the printer is fully enclosed and the heated bed is set to 100 degrees Celsius, the chamber temperature can stay above 40 degrees Celsius during the whole print. The crate turns out okay, with no warping and no layer cracking, and the retraction is also clean. I will also try using some flexible TPU to print this tire model. The extruder also works well with this Eryone TPU with a print speed of 60 millimeters per second. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The build quality is high with well-polished details, just like other SnapMaker machines. The overall build quality is at the same level as BambuLab, and the hardware used on this machine is even better. 2. The firmware is tweaked well. Even with Marlin firmware, it can achieve almost clipper-like print speed with reasonable print quality. Most PLA models were printed at 200 milliliters per second with up to a 6K acceleration using the default PLA profile. 3. The dual extruder calibration is handy. It's smart to use the CNC probe method to calibrate the X and Y offsets of both extruders, unlike other budget IDEX printers, where you need to print patterns a few times and try to adjust it up and down and left and right, meaning you need to take 30 to 60 minutes just to calibrate the X and Y offsets. I just used the setup wizard, and it calibrated successfully in one try, and I can print with multiple filaments without any issues. 4. One major problem with IDEX printers is that you have to make sure both extruders are at the same height. Using the nozzle to probe the calibration spots on the PCB heated bed works well. The semi-auto solution shows a gauge on the screen, so you can achieve a pretty accurate result, or at least it's more accurate than any other IDEX printer I've ever tested. 5. Compared to a multiple filament system with a single extruder, like the BambuLab machines, IDEX printers have their own advantage. The best part is the print speed. It doesn't need you to waste 2 to 3 minutes to flush the previous color from the nozzle every time when you switch colors, resulting in a lot of saved time and filament. Just a small prime tower for nozzle wiping is totally acceptable to me. 6. When printing support with different materials, like a PLA model with PETG support, an IDEX printer makes it possible to print filaments with different temperatures on the same model. As special support materials can be expensive, using PETG as support when printing PLA can save a lot of money. This method was introduced to me by a friend from Australia, Mickey, a few years ago. 7. The network printing feature works locally, so you don't have to worry about uploading your files to the cloud and raising any security concerns. Now for the cons. 1. The Marlin-based firmware doesn't support using an accelerometer for input shaper calibration, so you need to select the best part from the test model. As a result, the surface quality of decorative prints is not as good as those latest generation Clipper machines. 2. The linear advance also needs to be calibrated manually like an old Marlin printer. You need to go through the exact same process if you want to improve the overshot corners to make the parts fit each other better. I think SnapMaker can pre-calibrate the K values using generic PLA, as I found that most PLA works pretty similarly. 3. Their own slicer Luban works pretty well, and I don't have any major issues with it. There's just some minor bugs like a longer slicing time for more complex models, or the software may not respond after the print finishes, as I keep it running in the background for the entire week to test out the machine. It's better than most supposedly self-developed slicers from other manufacturers, but it's just not as good as Prusa Slicer or Bambu Studio. While you may have less control of how the printer prints with this Luban slicer, it's still fully functional, and all test prints in this video were sliced using their software and printed over my local Wi-Fi network. 4. It uses Bowden tubes to work as filament guides. You can see this approach on many enclosed printers, but the angle of the tube has a 90-degree sharp turn that makes some filaments like the high-temperature support material or other more brittle filaments snap. When I print with that kind of filament, I have to remove the Bowden tube from the coupler to prevent the filament from snapping. You can see there are some users making mods on the top cover to extend the height so they can still fully enclose the printer when printing brittle filaments. 5. The nozzle clogs when I try to switch back and forth from PLA to polycarbonate. Generally, if you print filaments with a big temperature difference, it's better to use 2 sets of hot ends. However, this is a quick fix. As most filament clogs occur at the heat breaks, you can simply take out the hot end, use a heat gun to heat up the heat breaks, and then use a 1.5mm ball head hex driver to push the filament out. It's not too big of a deal for users with some experience, as every extruder can clog, but it can be pretty frustrating for beginners. 6. The machine comes with 2 standard extruders with brass nozzles. If you need to print nylon carbon fiber or other abrasive filaments, you need to spend around $88 to buy a pair of hardened steel hot ends. It's a bit weird to sell hot ends in pairs, and in my case, I can't think of a situation where I need to print abrasive filaments with abrasive support, so just getting one hardened steel hot end will be good enough for me. In conclusion, the SnapMaker uses a different approach for multi-filament printing. If you are looking for a high-speed clipper machine that prints PLA quickly, there are better options out there. But if you want to make parts with engineering-grade materials like polycarbonate and high-temperature support, using this dual extruder machine is much better than the BambuLab A1s, which prints multiple filaments with one extruder. This prints faster and wastes much less filament. Besides that, the enclosure also allows you to print ABS or any filaments that require a stable ambient temperature. Previously, I have tested a few IDEX printers, but this is the best one available, so I will reward it with the title of the best performing IDEX printer on my recommendation list. If you're interested, you can visit my website auroratechchannel.com for my recommendation list, as well as a 3D printer price tracker tool that monitors over 100 popular 3D printers, laser engravers, and CNC machines with updates every hour. I also put the link to the SnapMaker J1s under the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.